Hello wonderful person, this is Anton, and in today's video we're going to take a look at the newly discovered Earth-like planet around our neighbor Proxima Centauri. This is the star that you see in front of you right now, and we're actually going to talk a little bit about why it took us so long to discover it, where it's actually located, and basically recreate this in Universe Sandbox² and then possibly even maybe terraform it if it all goes fine. If you haven't subscribed to this channel, click that subscribe button right now because there's so many more educational videos coming in the future. Welcome to What the Math. And so let's actually start by essentially talking a little bit about where this particular exoplanet is located. So if I were to move away from our solar system and if I were to actually add a star by the name of Proxima Centauri, which is already here actually, and we can possibly even add it as a whole system. It is at a distance of about 4.1 light years away. So as you can see, it's relatively far, but it is the closest star to us, which is why it's so exciting that we've discovered it. So this is 1 light year, 2 light years, 3 light years, and right around here. Alright, so that's Proxima Centauri. And around this particular star, we've discovered an object that is very Earth-like, in terms of mass at least. Maybe it's not so much in terms of atmosphere and temperature, but definitely in terms of mass. Now, as you can see, there's currently nothing around the system. That's because the game hasn't really been updated, so we don't really have any planets around it. So we're going to have to edit manually. We're going to go into planets here, and we're going to select a random rocky planet and place it at a distance that is actually within the so-called habitable zone of this object. So it possibly might even have liquid water. And so here is the Proxima Centauri B planet that is orbiting around Proxima Centauri. We're going to slow this down a little bit. One orbit here takes about 11.2 days. So it's actually relatively close to the star, much closer than Mercury is to the Sun. But because this is such a small star, because it's only about, in terms of masses of Sun, it's only about 12% mass of Sun, it doesn't actually produce that much light. Or doesn't really produce that much heat, so it's technically, if I were to go in here under view and enable the habitable zones, you'll see that it's technically actually within the habitable zone. It's within the disk where you can have liquid water. And so there's actually a possibility that, depending on atmospheric pressure here, just maybe Proxima Centauri B does have liquid water, which is super exciting. Now, let's actually, before we talk more about it, let's go into its material settings and make sure that it actually does have just a little bit of water. And we also may want to add... well, no, you know what, the rest looks fine. I think this is pretty good so far. So it just needs to have a little bit more water so that we have something on the surface that might actually end up melting later on. But as you can see, because it's actually, even though it's so close to the star, because the star is so small and it's actually quite well visible from this distance, the temperature, the surface temperature here is a little bit too cold. It's like minus 190 degrees, although it's possibly increasing. Yeah, it is slowly increasing. So we'll see how warm it gets here, but I don't think it's going to be as hot as Mercury or Venus because this star is just not really powerful enough to produce enough heat. And it seems that the temperature actually stopped around minus 20 degrees Celsius, which is still relatively cold. It's below the freezing point of water, so if there is any water on the surface, it would very likely be frozen unless, of course, there is some sort of atmosphere, which is what we're going to be creating right now. We're going to add... let's just say a perfect Earth atmosphere, one Earth atmosphere, and then see how warm this star gets, or this planet gets after a while. And chances are it's actually might get a little bit too toasty here. So anyways, so let's talk a little bit about its discovery and why we actually are so excited to have found it. First of all, how do we actually find it? Well, it took about almost 20 years because we were looking at the star for a long time, but we really haven't seen anything because, well, first of all, it's very dim, it's hard to see, and this planet would be very almost invisible essentially. So the way it was found was by using, let me just show you by creating a Berry Center here, by using the so-called wobble. And the wobble occurs when a star has something orbiting around it. Now, it's kind of hard to tell here, it's a little bit easier to actually see this with Sun and Jupiter, which is why I think I'm going to go back to our solar system for a second. So this right here shows you the barycenter, or the center of gravity between Sun and Jupiter. I've selected both Jupiter and Sun, and I've created barycenter. So here, this kind of gives you an idea that our Sun actually moves around this point in this way. It will obviously take a long time to see this, but let's see if we can maybe recreate this by increasing the speed of the game. And so here we go. You can kind of see that it's slowly moving as the days progress. And so this is how the stars wobble when there's objects attracting them using their own gravity. So every planet does that to our sun, and obviously every planet would do that to a star as well, including star like Proxima Centauri, which is right there. And as this exoplanet orbits around Proxima Centauri, it essentially makes it go back and forth, back and forth, back and forth. And so every 11 days, or actually no, sorry, every, I guess, 5.6 days, or 5.5 days, this star will move a little bit slower or a little bit faster, a little bit slower, a little bit faster, and that's because of this wobble. And because of this, the light emitted by this star gets some sort of a Doppler shift effect. And if you don't really know what Doppler shift effect is, here's kind of a picture that gives you an idea. Basically, the light coming from Proxima Centauri gets a little bit red shifted and blue shifted every 5.5 days because there is this planet orbiting around it. But because this star and this planet are so tiny, it's actually very, very difficult to see, and so the only reason we've detected it was because Proxima Centauri is so close to our sun. If it was anywhere farther away, we would not be able to see this effect as easily as we have this time. Because the changes in speed here are very, very small. So when, like for example, right now, when the planet is closer to the star, the speed increases by about 5 kilometers per hour. Here, the speed decreases by 5 kilometers per hour. So it's very, very, very minor increases in speed, which cause very minor Doppler shifts. But nevertheless, because they are so close together, which is why it's called Proxima. Proxima means proximity, close, which is why we were able to essentially see it. Now, I still actually have to change the mass of this planet because I totally forgot to do that, because we know for a fact now that the mass here is about 1.3 masses of Earth. So this planet, which already has liquid water, as you can see, is actually a little bit more massive than Earth. But the gravity effects here would be relatively similar to Earth, especially if it doesn't have as much iron as Earth. So in terms of surface gravity, it currently says 11.1, but if I actually play around with materials, the surface gravity will change accordingly. So if it actually has a lot less iron, if it's mostly rock, its surface gravity is going to be very, very similar to the one on our planet Earth. And in terms of size comparison with Earth, it's actually very, very Earth-like as well. So it's maybe just a little bit bigger, which is actually super exciting because not only did we find an exoplanet so close to us, but it's Earth-like. It is within the habitable zone, and for all we know, this is actually what it might look like. As you can see, it's already terraformed. It's actually, if you go into materials and you look under Earth similarity, it's 96% Earth similar with a 80% chance of life. And I didn't even do much. I didn't even have to try to terraform this. Now, the temperature is still kind of increasing a little bit, but so it might go up a little bit higher because of the atmosphere I put. So, really, all we need to know now is whether this planet actually has atmosphere or not. Because if it does, it might look like this, and if it doesn't, it might look very frozen, very cold, but still very interesting to visit. Now, one thing about this is that it's actually, or it might be actually, tidally locked. So, in other words, it actually might be always facing the same side, or in other words, the same side is always facing the star Proxima Centauri. So this would mean that one side would always be very, very hot, other side would be very, very cold. So unless there's actually atmosphere to distribute this heat, we might only be able to kind of live on these like twilight areas right here. Or maybe a little bit closer because it wouldn't be super, super hot since the star is much smaller than ours. But all in all, this is actually such an exciting finding, it possibly even more exciting than Planet 9 because, you know, if we need a new home, if we need a new planet to live on, it's actually surprisingly close to us. And it's actually possibly even terraformable and colonizable. But of course, there's still a chance that maybe, just maybe, this is actually not a terrestrial planet. Maybe this is some sort of a very small, very tiny gas giant, or I guess you could call it gas dwarf. Or maybe, just maybe, this is actually something else, some kind of a very large object that we haven't really discovered yet or haven't seen before. But currently, the chances is that it's actually a terrestrial planet, slightly more massive than Earth, very, very close to us, and is technically reachable if we use some kind of a technology that we already have within, I don't know, something like 20, 30, 40, 50, 60 years, depending on the speed we were able to achieve using conventional technologies. For example, if we were to use the so-called Orion engine, which uses nuclear weapons to essentially create propulsion, and if we were to continuously use those nuclear propulsion thingamajiggies to try to get to Proxima Centauri, it would possibly take us about 60-ish years to get here. So it's not impossible. We already have technology that is capable of taking us here. But all in all, I think this is actually really, really exciting because this is possibly going to be the center of scientific discovery and attention for the next few years, because we didn't really expect to find this here. This was, mentioned in so many different science fiction novels, including, of course, the movie Avatar. Although I think in Avatar it's not around Proxima Centauri, it's around Alpha Centauri. And of course, we also have games like Civilization that deal with the idea of trying to colonize Alpha Centauri system. And of course, there's a game called Alpha Centauri that does allow you to go on this, not on this planet, but a planet around Alpha Centauri and try to survive there. But surprisingly, it is actually even better than Alpha Centauri because Proxima Centauri is slightly closer to us. It is the closest star next to us. And anyway, so I think this is a terraformed planet now. As it stands currently, the actual Earth similarity is 97%, and life likelihood actually decreased for some reason, but I'm guessing it's because the temperature has changed a little bit as well. Now, we still don't really know if there's going to be a magnetic field here or not, and if there is no magnetic field, because it's so close to the star, it's very likely that there is actually no atmosphere anymore and it's all been completely stripped. So this planet might be completely naked. There might not even be any water on it because due to the proximity to the star, maybe, just maybe, the water has also been stripped from the surface. But for now, let's just dream and hope that this is exactly what this planet looks like, and this is going to be the future home of our species, and of course, we'll be able to colonize it one day. Anyway, thank you so much for watching. Hopefully you learned something from this video, and hopefully now you know about Proxima Centauri B, about which we'll be talking more in future videos as well. If you still haven't subscribed, click that subscribe button right now, because there's so many more videos coming in the future. I'll see you guys in the next video, game you later, and as always, bye bye. And just to help us dream a little bit more, let's actually put a few moons around this object, just to see if, or what this would actually look like if it also had other objects orbiting around it. Maybe it has 2 moons, or possibly even 3 moons, that are very, very large, similar to our own moon as well. And maybe, just maybe, one of these moons, like Titan, decides that it actually wants to come for a collision. And the end. No more home for us. The planet has been completely destroyed. This is a universe sandbox game, and you can't really finish a video without colliding something with something else. Anyway, thank you for watching, guys. Bye-bye.